Howdy, folks. This is lesson 3.3 for ninth grade math, the summer edition. I'm Mr. Ryan, and in this particular lesson, we're going to review something that you've probably done before, but we're going to do it very specifically relevant to algebra. It's the subject of prime factorization. It has to do with prime numbers. This is a really important subject if you plan on having a job, let's say, or being involved in programming or internet security or something like that, because prime numbers are very important in the world of computing. They're very useful. Well, let's just jump right into it. Okay, so I want to briefly review, make sure we understand the difference between a prime number and a, whoops, wrong button there. The difference between a prime number and what we call a composite number. Okay. All right. And I mean, one way of understanding the difference between a prime number and a composite number is, prime numbers are only divisible. You can only divide them. Now, divisible, I'm saying into a whole number. Okay. They're only divisible by 1 and itself. Okay, so for example, 2 is a prime number. So 2 divided by 1 is equal to 2, and 2 divided by 2 is equal to 1. Okay, but you can't divide 2 by any other number and get an answer that's a whole number or an integer. Okay. Well, let's say whole numbers for now. Okay. Another example of a prime number, for example, would be 13. Okay, so if you divide 13 by any number other than 1. Okay, 13 divided by 2 is a decimal, and that's 6.5. That's not a whole number. Therefore, 13 is, well, presumably prime. If we did 13, can't do 13 divided by 3. Can't do 13 divided by 4. Can't do 13 divided by 5. Okay. 13 is not divisible by 6. It's not divisible by 7. By the way, you can't really ever divide a number by another number that is larger than half the number. So half of 13 is 6.5. So anything larger than 6.5 is not going to divide into 13. Okay, except for 13, because we know that 13 divided by 13 is 1. Okay. And so again, 13 is divisible by 1, because 13 divided by 1 is 13, and it's divisible by itself. 13 divided by 13 is 1. That makes it a prime number. Composite numbers, on the other hand, can be divided by themselves, 1, and at least one more number. Okay? So for example, 4, let's see here, 4 can be divided by itself. 4 divided by 4 is 1. 4 can also be divided by 1. 4 divided by 1 is 4. But 4 can also be divided by 2. And 4 divided by 2 is 2. And therefore, 4 is a composite number. Another number that is composite is 6. Okay, so 6 divided by 6 equals 1. We know that. And 6 divided by 1 is equal to 6. Okay, that's fine. But we can also do 6 divided by 2, which is 3, and 6 divided by 3 is 2. And that makes 6 composite. Every number is either prime or composite. We do not count the number 1. The number 1 does not count. It is not prime. It is also not composite. It's its own number. So starting at 2, 2 is prime. Let's come over here. Actually, I'm going to erase some of this stuff. There we go. Erase a bunch of stuff. It's not erasing as fast as I wanted it to. There we go. There we go. Okay. So what I want to do is I want to make a list of the numbers that are prime and the numbers that are composite, starting at, well, we're not going to go very far. Okay, so 2 is prime. 3 is also prime, but 4 is composite. 5 is prime. 6 is composite. 7 is prime. 8 is composite. Okay. Also, 9 is composite because 9 is divisible by 3. 10 is composite because it's divisible by 2 and 5. 11 is not. 11 is prime. Okay. Looks like I'm having trouble with my pen here. All right, 12 is composite. 13 is prime. And 14 is composite. 15 is composite. 16 is composite. 17 is prime. 18 is composite. 19 is prime. And 20 is composite. Let's stop there. I want you to notice something. Every even number other than 2 is composite. So 4, 6, 8, 10, 12, 14, 16, 18, all composite. Why? All even numbers are divisible by 2. 2 is the only even prime number. All other prime numbers are odd numbers. Okay? Now, we in this particular section, just to make things sort of simpler, we're going to stick with just 2, 3, 5, and 7. So we're only going to deal with primes 2, 3, 5, and 7. So you don't have to worry about 11, 13, 17, 19, 23, 29. You don't have to worry about any of that stuff. Okay? So that's our review of prime numbers. Okay, so now that we understand or remember, or the difference between a prime number and a composite number, there's something, a math fact that is important for what we're going to do, is that any composite number, all right, any composite number can be factored. Okay, can be factored. The word here is factored. That means divided down into. Can be factored into the product. Oops. Into the product of a bunch of prime numbers. This is not a technical term, a bunch of, just that's the way I want you to think of it. A bunch of prime numbers, okay? So you give me any number that is not a prime number, okay, and I can break it down into a product of several prime numbers, okay? And that's called, when we do that, it is called the prime factorization of a number, okay? So for example, the number 8, okay? We know that the number 8 is equal to 2 times 4, okay? But 4 is not a prime number. 4 is a composite number. 4 is equal to 2 times 2, which is 2 prime numbers. And therefore, if we replace this 4 with 2 times 2, we wind up with 8 is equal to 2 times 2 times 2. And that is a prime factorization of 8. Now, I want to remind you, in the world of math, when we multiply a bunch of numbers that are the same, we use exponents as sort of a shortcut. So that 2 times 2 times 2 is the same thing as 2 to the third power. And so here's what we would say is that 8 is the same thing as 2 to the third power. That is the prime factorization of 8. Okay? What about 10? Well, 10 is equal to 2 times 5. Both 2 and 5 are prime. Therefore, this is the prime factorization of 10. Okay, so we can write 10 as 2 times 5. What about 14? Well, 14 is 2 times 7, right? How about 15? 15 is 3 times 5. That's 2 prime numbers, so 3 times 5 is the prime factorization of 15. Okay. What about, let's do one more. How about 30? 30 is the same thing as 10 times 3. You could also say 6 times 5. And 10 is the same thing as 2 times 5. So we would have 2 times 5 times 3. Now the way we would write this, actually, we would write it in order. 2 times 3 times 5. Okay? 2 times 3 is 6. 6 times 5 is 30. 3 times 5 is 15. 15 times 2 is 30. So any way you look at it, it's 30. This is the prime factorization of 30. Okay? Okay, so we're gonna come back to this in a few minutes. Before we continue with prime factorization, which is the main focus of this lesson, what I now want to do is I actually would like to for you to practice being able to take a prime, start with a prime factorization, and be able to calculate it using a calculator. Okay, and so one of the things I'm going to do right now is I'm going to open up the Numworks calculator. Okay, here we are at the Numworks website, and then we're going to go to emulator, and then we're going to go to full screen, and we're going to use calculation here. So we're going to make sure that we're highlighted on calculation, then we're going to hit OK, and here's where we're going to use the calculator. Okay, and so the idea goes like this. We're going to use this calculator to be able to calculate out prime factorizations. Okay, so for example, let's say we wanted to identify, let's say we had 2 to the third power times 3 times 5 times 7 squared. Okay, so as you can see here, 2 is a prime number, 3 is a prime number, 5 is a prime number, and 7 is a prime number. And we have exponents, so this 2 to the third is the same thing as 2 times 2 times 2, and this 7 squared is the same thing as 7 times 7. So this is just another way of writing the prime factorization: 2 times 2 times 2 times 3 times 5 times 7 times 7. These are the exact same thing, okay, only to group these 3 2's together, we're using the third power, and to group these 2 7's together, we're using the second power. Okay, what we want to know is what is this number? This is the prime factorization, but we don't know what the number itself is. Well, let's find out what the number is. Okay, so what we're going to do is we're going to go into, I'm going to put equals here. We're going to say this number is equal to, we're going to go to Numworks, and we're going to type in 2 to the third power times 3 times 5 times 7 squared. Okay, so we go to Numworks, and we're going to type in 2 to the third power. So we hit 2. To get the third power, we have to go here to this button right here. If you click that, or if you push that button, it gives you an exponent, and we want the exponent of 3. So that's 2 to the third power. Now, in order to multiply, we have to hit the arrow, because right now we're inside of the exponent. We don't want to be in the exponent anymore. We want to come out of the exponent, so we hit the arrow button. Now we're going to hit times, then we want to do times 3, then times 5, then times 7 squared, so 7. But instead of using that button again, there's actually a special button just for squared. We're going to hit that button. So look what we have. We have 2 to the third times 3 times 5 times 7 squared. And if we hit execute or enter or equals, this is what we get, 5,880. And therefore, this is the prime factorization of 5,880, okay? And we could also write it like this, 5,880, because this is also the prime factorization, but it does not use exponents, okay? But this is the same thing, okay? So why don't you try one? Why don't you go get the Numworks calculator? Maybe you have the app on your phone, or maybe you can open it up on your computer, and this is what I want you to identify. I want you to calculate 2 to the third power times 3 squared times 5 times, okay, let's call with my pen, 7 to the third power, okay? All right, so pause the video, write this down, go over to the Numworks calculator, and calculate it. All right, so I'm going to do that now. So let's see here, I'm going to do 2 to the third, 3 squared, so 2 to the power of 3, then I'm going to come out of the exponent, times 3 squared times 5 times 7 to the power of 3, okay? There we go. And now I'll hit execute, and we get 123,480. Okay, so 123,000. 123,480. Okay, and that is and so this is the prime factorization of 123,480. Okay, let's try another one. Get ready with your Numworks calculator. I want you to do 2 times 3 to the 5th, 3 to the 5th power. That means 3. We're doing 5 threes. 3 times 3 times 3 times 3 times 3. Okay, times 5 squared times 7. Now, if you want to, you can just in a calculator do 2 times 3 times 3 times 3 times 3 times 3 times 5 times 5 times 7. You don't have to use the Numworks calculator. I just think the Numworks calculator with exponents makes it a lot more convenient. All right, so we're going to do 2 times 3 to the power of 5 times 5 squared, okay, and then times 7. Yep, that's the one. And I hit execute, and we get 85,050. 85,050. Okay, 85,050. 85050. Okay. Let's just try a couple more here. How about 2 to the 2nd power times 3 to the 5th times 5 squared times 7. Try this in the Numworks calculator. All right, I'm going to go ahead and do it. So we got 2 squared times 3 to the 5th, come out of the exponent, times 5 squared, and then times 7. Now I want you to notice something here. This is the exact same one we just did. 7 to the 1st power, 5 to the 2nd power, 3 to the 5th power. The only difference is that instead of being 2 to the 1st power, it's 2 to the 2nd power. So really, this is going to be the exact same thing as this, except multiplied by 2. We're multiplying by 1 more 2, okay? And in multiplying by 1 more 2, all we're really doing is doubling 85,050. So let's see if it's double this. We'll hit execute, and sure enough, in fact, if I divide this by 2, if I take my answer here and I divide it by 2, I'll bet I get 85,050. Sure enough. But this other one we're doing now is 170,100. So this is 170,100. Okay? Let's just do one more. How about 2 to the 3rd times 3 squared times 5 to the 3rd times 7 squared. Okay? Pause the video. Go use the Numworks or TI-84, whatever you want to use, and see what you get for this one. Okay, so I'm going to use the Numworks. I'm going to do 2 to the 3rd and then 3 squared. 2 to the 3rd, come out of the exponent, times 3 squared times 5 to the 3rd, come out of the exponent, times 7 squared. All right, execute. I get 441,000. All right, so let's come back here. This is 441. You don't have to use commas. You can use commas if you want to, but you don't have to. 441,000. Okay. All right. So that's it for. I just wanted to show you what it looks like when you take the prime factorization of a number and then multiply it out. This is what you get. I am going to show you a neat feature of the Numworks calculator real quick. See this 441,000? If I go into the Numworks calculator, I can actually get the factorization of it. The Numworks calculator will do that for you. What I'm going to do is I'm going to go to this button right here, which is called the toolbox button. I'm going to click on the toolbox button, and then what I'm going to do is I'm going to go down to where it says arithmetic. Okay, arithmetic, and then I'm going to hit the right arrow, and then that's going to go in here. And look at this factor. Do you see where it says factor M? That says prime factorization. This will do the prime factorization of any number. So then I'll hit execute, and now it says factor. Well, I want to factor this number, 441,000. 441, 1, 2, 3. And once I hit enter, watch this, totally cool. Look at this. 2/3 times 3 squared plus, or times 5/3 times 7 squared. It's the exact same thing. So the Numworks calculator is amazing. Not only can you key in the prime factorization and get a number, but you can actually put in the number using the factor feature, and it'll give you the prime factorization, which is going to be very useful for this lesson that we're going to be doing pretty soon here, okay? All right, so I think I'm done for now with that section with the Numworks calculator. Let's now go ahead and do some prime factorizations. Okay, here's a few examples. We're going to identify the prime factorization of these 2-digit numbers. So typically the way I go is, these are all even numbers. Anything that's an even number can be divided by 2. So if we use a calculator, we can divide by 2. 36 divided by 2 is 18 times 2. Now 2 is prime, so we're going to leave that. We're going to leave that alone, and we're now going to take the. Well, we're going to carry it with us, but we're going to now multiply. Well, what is 18? 18 can also be divided by 2. 18 is the same thing as 9 times 2, and then we'll put that times 2 on there. See that? This is 18, so this is 18 times 2. Now we can break up the 9. We know that 9 is 3 times 3, right? So we can do 9 is 3 times 3, okay? And then we have times 2 times 2, times 2 times 2. And so what we have here is 3 times 3 times 2 times 2. I want to put the 2's first. How many are there? There's 2 of them. So I'm going to go 2 squared times, then 3's. How many 3's are there? There's 2 of them. So I'm going to do 3 squared. So 36 is the same thing as 2 squared times 3 squared, okay? And there's other ways to do this. You can do, for example, if you did 3 times 2, that's 6. Then we have another 3 times 2. That's another 6. And 6 times 6 is 36. 2 squared is 4. 3 squared is 9. And 9 times 4 is 36. So any way you look at it, this 36 winds up being 2 times 2, 3 times 2. Okay? I mean, not times 2, 3. 2 squared times 3 squared. Okay? Let's do it with 40. Now, the great thing about something that ends with a 0 is anything that ends with a 0 is divisible by 10. So 40 is divisible by 10. And 40 divided by 10 is 4. So this is the same thing as 4 times 10. Okay? Now, 4 is composite and 10 is composite. So we can break them both down. 4 is the same thing as 2 times 2, and then times. 10 is the same thing as 2 times 5. And so these are now all prime numbers. So we have 2 times 2 times 2 times 5. And so this is 2 to the 3rd power times 5. That is the prime factorization of 40. Okay? It's not the prime factorization of any other number. All numbers have a unique prime factorization. That's one of the things that makes them so useful in computer programming, because these are unique circumstances, and they can then be used for internet security. It's a really, really neat idea. Okay, 72 is an even number, so we can divide by 2. 72 divided by 2 is 36, so we have 36 times 2. All right, 36, we've already seen up here, 36 is 2 squared times 3 squared. So we can just throw that in. Okay, so we've got 2 times 2, that's 2 squared, times 3, and then times an extra 2 here. There's our extra 2. Okay, and so what we now have is 1, 2, 3 2's, so that's 2 to the 3rd power, times 3 squared. 3 squared, okay? And then 2 to the 3rd we already saw is 8. 3 squared is 9, and 8 times 9, that's 72. And so we have the prime factorization of 72. Let's do one more here, 84. 84 is even, and therefore it's divisible by 2, and we would wind up with 42. Oops, 42. Why my pen's not writing? Okay, there we go, times 2. All right, 42 is also divisible by 2, so that becomes 21 times 2, and then we have times 2 again. Well, what about 21? Well, 21 is 3 times 7. So we wind up with 3 times 7 times 2, and then times 2 again, times 2. And so we wind up with 2 times 2 times 3 times 7, and that's 2 squared times 3 times 7. And therefore, that is the prime factorization of the number 84. Okay, let's try a few more examples, maybe some bigger ones, some ones that are a little more difficult. Okay, so these numbers are a little bit bigger, so they're going to take a little more time, and you're definitely going to need a calculator for some of these. Okay, let's start with 1512. So I'm going to go to the Numworks calculator. This is an even number because it ends with a 2. Okay, a few notes. Anything that is an even number or if it ends with 2, 4, 6, 8, or 0, it's an even number. Okay, anything that ends with 0 is divisible by 10, and anything that ends with 5 is divisible by 5. Okay, so that's important to understand. So 1512 is an even number, so we're going to go here and we're going to do 1512 divided by 2, and we get 756. Okay, so we can say that this is 756 times 2. Well, 756 is also an even number, and so we're going to divide 756 divided by 2. Okay, and we get 378. That's also an even number. Okay, so let's go here. 378. So what we now have is 378 times 2 times 2. Okay, you got a bunch of 2's here. So we're going to divide again. Now I want to show you something cool about this Numworks calculator. As long as you're not subtracting, if you're dividing, you can just, all you have to do is hit the division button. Okay, you can hit the division button and it'll take this answer and automatically put it in. And then we're going to divide by 2 again, and we get 189. Now this is not an odd number, or an even, sorry, it's not an even number. Therefore, it's odd, so we're done dividing by 2. Okay, so this is going to be now 189 times 2 times 2 times 2. Okay, and so now we need to divide 189. Well, 189, remember, these are the numbers we're dividing by. We're dividing by 2, we're dividing by 3, we're dividing by 5, and we're dividing by 7. We can divide by 2 when the number is even. We can divide by 5 when the number ends with a 5 or with a 10. Okay, so this 189 right here, it can't be divided by 2 and it can't be divided by 5. So I suggest let's divide it by 3 or let's divide it by 7. Let's try 7. So I'm going to divide 189 divided by 7. And look at that, it worked. I got a 27. And so now this is the same thing as 27 times 7 times, and we so far have had 3 2's. Let's just do 2 to the 3rd power, okay? Now, 27 is a cool number because 27 is actually 3 times 3 times 3. So if we divide 27 by 3, you can see we get 9, divide that by 3 again, and we get another 3, okay? And so 27 really is just 3 to the 3rd power, okay? And so let's go back here, and what we now have here is this 27 is 3 to the 3rd power, okay? And then we have times 7, and then we have times 2 to the 3rd power. So this winds up being, if we put it in order, 2 to the 3rd power times 3 to the 3rd power times 7, okay? And if we were to key that in to Desmos, watch what we would get. 2 to the 3rd power times 3 to the 3rd power times 7 gives us 1512, which is what we started with, okay? And so we got the prime factorization. We're good, okay? Now let's try 1323, okay? So what I'm going to do now is I'm actually just going to use Numworks. I'm going to show you how I can do this pretty quick. 1323 can't be divided by 5, can't be divided by 2. Let's try dividing by 7. I get 189, which we already know. We already know what 189 is. So 1329, or 1323, very simply is 7 times 189. And we already know what 189 is. It's 27 times 7. All right, so this is going to be 7 times 27 times 7, We know 27 is 3 to the third power, and we know 7 times 7 is 7 squared, and so 3 cubed, 7 squared is our prime factorization of 1323. 84,000, we can actually do that as 84 times 1,000. Okay, so these are both composite numbers, but we can do them separately. 84 divided by 2 is 42 times 2, all right? And 1,000 is the same thing as, so we're multiplying. 1,000 can be divided by 2 or 5. Let's divide it by 2. If we divide it by 2, we get 500. 500 times 2, okay? Now, 42 is divisible by 7. So we wind up with 7 times 6 times 2. All right, here, the 7 times 6 is our 42, times 500. This right here is divisible by 5. Okay, so we have 100 times 5 times 2. Okay, we can break it down even further. The 6 right here can be divided by 3. It's 2 times 3. So what we wind up with is 7 times 3 times 2 times 2. Okay, that's one of them. And then this other one, 100 is 10 times 10. 10 times 10. And then we do times 5 and then times 2. Okay, and then these 10s actually each become 2 times 5. And this 10 is also 2 times 5. Okay, and then we also have times 5 times 2. Okay, and so what we wind up with here is 7 times 3 times 2 times 2 times, now we're going to do these, times 2 times 5 times 2 times 5 times 5 times 2. Okay, and then we're going to count them up. 1, 2, 3, 4, 5 2s. And so this winds up being 2 to the 5th power. There's 1 3, so but times 3. There's 1, 2, 3 5s, so 5 to the 3rd power. And then there's 1 7 times 7. So it winds up being the prime factorization is 2 to the 5th times 3 times 5 to the 3rd times 7. And now I'm going to show you how we could have done that in Numworks. Our number is 84,000. So if we go to Numworks, we can go to Factor. Now let me remind you how we got here to Factor. We hit the toolbox, then we arrow. Normally it starts up here. We arrow down to where it says Arithmetic. It's Arithmetic. Go over, and then down the 3rd one, Factor, and then hit OK. And we're going to put 84000, hit execute, and look, there it is, 2 to the 5th times 3 times 5 to the 3rd times 7. Okay, and so now we can do the exact same thing with 117,600. Let's take our factor, okay, and go here. It's 117,600. Execute. Here it is, 2 to the 5th times 3, 5 squared, 7 squared. So let's come back here. 5 squared, 7 squared. So it's 2 to the 5th times 3 times 5 squared times 7 squared. That was pretty fast, wasn't it? I think it was pretty fast. Okay, and we'll do this last one. We'll call it quits. 270,000. We're going to use this factoring feature. We're going to go 270, 1, 2, 3, execute. We get 2 to the 4th, 3 to the 3rd, 5 to the 4th. So 2 to the 4th times 3. Oops. Hang on a second. All right. 2 to the 4th times 3 to the 3rd times 5 to the 4th. Okay? And that's it. And then what we've done in this lesson, lesson 3.3, is we've just done the prime factorization. And I want you to be able to take the prime factorization, multiply it out, and get a number. I also want you to be able to take the number and identify the prime factorization. And that is going to be important in lesson 3.4. Lesson 3-4, step 1 of what we learn is going to be to identify the prime factorization of a number. Okay? All right, I'll talk to you later. Let me know if you have any questions.